Okay, we're back to our code editor, and I'm located in lecture 34, which is located in full stack-course 5 examples folder. And this is once again our shopping list application, which is now called shopping list events app. There are many times in applications when there's some asynchronous communication going on, and while that's taking place, because usually that takes a little bit, you need some sort of a spinner or some sort of graphic to tell the user that something is going on and he should wait. So what we're going to do is when a shopping list item is added to the shopping list, we're going to kick off a whole bunch of asynchronous actions, each of which will check whether or not a particular item in the list contains the word cookie or not. Now, since there could be more than one item in that list, we're going to have more than one asynchronous action being fired. However, while those asynchronous actions are being resolved, we would like to show some sort of indication to the user that something is going on, so we're going to display a loading spinner that is actually going to be our Flickr button. And if you heard of Flickr.com, this is what their loading icon is like. And since we don't really know where this particular behavior is going to reside, we're going to place our loading spinner component, yet another component we're going to have in our application. We're going to place it outside of our controller. So it's not even inside of our shopping list controller. As you can see, the div ends right here. It's actually sitting completely outside of it, but it is still sitting inside of the ng app directive, which means it's inside of our Angular application. So let's go to our app.js and take a look at the code. Let's actually minimize the file browser, so there'll be more room here. So as you can see, we have one more component called loading spinner, and all that component has is a spinner.html template URL and a spinner controller. Well, the template URL for spinner.html is very simple. It's just an img tag, and it has an ngIf in it, meaning it will get shown, this img will be part of the DOM if this $ctrl.showSpinner is true. Otherwise, it will say false, and the entire img tag will be pulled out from the DOM rendering. Going back to our app.js, you'll see we have a starter here. We started our spinner controller, and we already injected the root scope, and you'll see why in a minute. And this is just the starter one. Well, let's take a look at a very important part of the code, which is inside the shopping list component controller. That's the thing that displays the shopping list. And we injected a couple of things here. We injected our queue service, if you remember from when we spoke about promises, and we also injected this weight loss filter service. That's an asynchronous service that checks for names of the shopping list to check to make sure there are no cookies in it. And we're going to invoke that service inside the $docheck. Again, $docheck gets invoked every time through the digest loop, and therefore we could check whether or not our number of items in our items array changed, and if it did, it means it's time for us to check whether or not there are cookies inside of our shopping list. Before, however, we make that asynchronous call to our weight loss filter service, we're going to broadcast an event. And notice that we're broadcasting an event using the root scope. And the reason that is because the component that needs to catch that is loading spinner, and it's completely not in our path of up the scope chain. So therefore, if we go back to app.js, we're using root scope, so we're starting from ng-app, starting from the very top component, and we're broadcasting that event down. And the event is called shopping list :processing. And the only data we're passing, really mostly for show here, is on, the property on in the object, and its value is true. So what this event should trigger somewhere in our application, we don't know where and we don't care, is it should show some sort of a spinner to the user saying, hey, we're processing, or maybe do some other things as well. But for our purposes, all we needed to do is actually show the spinner so the user knows something is going on. Then we're going to use our $q all, and the way we're going to do that is we're going to loop over every item inside of our items array, and for every item we're going to call this weight loss filter service and call its method called checkName, which returns a promise, and we're going to push every single promise into this promises array. As you can remember, the Q service, $Q service, all takes an array of promises, and then it can deal with them all at once. And that's actually what we want. We want them to be asynchronous and all of them to be parallel at the same time. And the reason we want that is because even if one fails, which means, even if one fails, it means that we detected a cookie in there, and we're going to go to this catch block, the rest of the promises will get canceled automatically right there on the spot. So the first time it detects a cookie, the rest of them will get canceled, and what's going to happen is it's going to do this jQuery stuff that we've seen before, where it's going to find the element with that error message and go ahead and slide it down. And if all of them come back with a positive result, which means none of the items in the shopping list actually contain the word cookie, then we're simply going to remove the error message if it's even there. In either case, however, whether it's good or not, we have a finally block that will broadcast yet another message using the $root_scope service, and it will broadcast shopping list processing and on with a value of false, which means we've completed all of our asynchronous communication, nothing else is being processed, so therefore go ahead and turn off that spinner. Okay, so we've set up broadcasting the on event when the spinner should turn on, and we've set up the broadcasting of the event that the spinner should turn off at the end of all this asynchronous processing. Let's go to our actual spinner controller and implement the event listener to catch those events. So the first thing we're going to do is we're going to go ahead and use our root scope that we injected right here into our controller. We're going to call this $on method, and the $on method is going to look for shopping list, all lowercase, processing, and that's the name of our event. And we need the handler function, we don't need the name, and it's going to pass us event and data. Okay, we'll put a semicolon here. And now we could actually log what the event is. So event, and we'll log what that is. And let's go ahead and also log what the data is. Okay, now let's go to our browser, and browser sync is already started. Let's go ahead and open up our console. And let's go ahead and add something like chips, 2 bags of chips, and we'll click add. When we do that, you could see a couple of things happen. Number one is the first event gets fired, and that event is an object. You could see it has a name. The name of the event is shopping list processing, and you could see the data as well that was broadcast to the entire tree, really, which is this object with the value, with the property on and a value of true. But you could see that there's yet another event that got broadcast, and another event that got broadcast was, again, shopping list processing, except with the object that it broadcasted was on false. So the first time when we started processing was this event. When the processing was over, this event was broadcast. Both of these events, however, were caught inside of our spinner controller right here. That's where we printed that out. The next step is fairly simple. We just have to check if data.on, because that's our on property. If it's true, that means we want to turn on the spinner, and that's easy. It's just controller.show spinner equals to true, and otherwise else our controller.show spinner is equal to false. Let's go ahead and save that. Let's go back to our browser and let's go ahead and try it. Let's say chips, 3 bags of chips. We'll click add, and we could see right there it's processing, so it's showing us. And once the second event comes in, that icon disappears. And if we say, let's move this down a little bit, and if we say cookies, the dreaded cookies, 3 bags of the cookies, and we click add, yet again it's processing. Now it's processing 2 events or 2 items in the shopping list, and it comes back with cookies detected. So if we remove that, again, once I remove it, it has to once again trigger the whole broadcasting, which is what it does. And again, it's checking to see that there's no cookies in here, and once it comes back, it turns off our animating icon. There's actually one more thing to do. If you take a closer look, this spinner controller and this spinner component altogether, this loading spinner component, will work very well in this view. But what happens if I switch views and come back to it, and then switch and come back to it? Every time I come back to it, we're going to have this $root_scope.on, so which means every time we will register this event listener, and there's really no code to go ahead and destroy this. This would be different if I just said something like this, scope. Why? Well, because every time that this view gets destroyed, the scope gets destroyed with it and anything that's attached to it. However, root scope is never destroyed until the entire application is destroyed. And here we have a potential for a really nice memory leak, because every time we come here, this on is going to get executed, but nothing actually deregisters it. Well, we'll learn of this handy method in the controller nowadays in the components called controller.$on_destroy. So when this is going to get destroyed, when the scope of this controller gets destroyed, we want to trigger the destruction of this listener as well. And the way we could do that is to say this is a function. We don't need the name of it. And what we need is we need to somehow get a hold of the function that registered this entire listener. And the way we could do it is fairly simple. The $on function actually returns a deregistration function. So all we have to do is say var cancel listener, and we'll make that equal to that. And in here, since it's a local variable that we can access, we'll copy that. We'll just say cancel listener, and now that we know that it's a function, all we need to do is put parens behind it, put a semicolon, and save that. And now every time this view gets destroyed and the scope, the $scope that belongs to this controller and belongs to this component gets destroyed, we'll also at the same time deregister our root scope.on. So it will not hang around even though we're no longer using the scope. Let's go ahead and check it out to make sure things are working. Let's put chips, 4 bags of chips, and add that. That seems to be working and should turn off in a second. Yes, it did. And now we're going to put cookies. Let's make it 5 bags of cookies. We deserve it. And there you go. That's spinning. And at the same time, at the end, bam, it says cookies. If we remove it, it will once again start spinning to check the items in the shopping list. You will see that the cookies are not there anymore. The spinner will stop and the warning will go away as well. Let's summarize. In Angular, the publish-subscribe design pattern is implemented using the Angular events system. You can publish events from anywhere in the system, and likewise, you could listen for those events and catch them anywhere in the system as well. There's a couple of ways of publishing events. One way is to use the $scope.$emit. That method sends the event up the scope chain. The other way is to call $scope.$broadcast, and that method sends the event down the scope chain. Obviously, your message or event reachability of a particular node will depend on where it is located in the scope chain structure, whether or not it's in the path of the broadcast or emit methods. So if it's not in the path, or to really reach all nodes, you use the $rootscope.$broadcast. What that does is broadcasts the message from the very top where you declare ng-app, which is really the root controller of our entire application, and therefore everything in our application inherits from its scope, and therefore everything is on its scope chain path. To listen for an event, you either use the $scope.$on or the $rootscope.$on. In either case, what you pass into those methods is the name of the event you're listening for, and you register a function that should be executed when that event gets triggered. While if you're listening for an event using the $scope.$on, there's really nothing left to do, because when you destroy the particular view, the $scope will get destroyed with it. That is not the case with the $rootscope, because that always lives throughout your application. So you must deregister the listener when using the $scope.$on. The way you deregister the listener is simply capture the return value of the $on method, which happens to be the deregistration function, and then you hook that into the destroy method of your component, and then calling that deregistration function inside of that. If you were to skip doing that, you would leave the listener function registered in memory basically for the rest of the life of this application. And what's worse, as you keep coming back to this view, new listener functions would be registered, and more of them would keep sitting in memory without any way to reach them and unload them from memory by deregistering their listening to the event.